Let's start with a powerful idea that every AI and engineering student should pay attention to, because it represents one of the fastest growing real-world applications of computer vision and robotics. Drone inspection AI is all about using drones equipped with cameras and sensors to automatically inspect critical infrastructure, and this shift from manual inspection to AI-driven automation is transforming safety, efficiency, and cost across entire industries. Traditional inspection of bridges, power lines, wind turbines, and high-rise buildings is slow, risky, and extremely expensive, and that's exactly why AI-powered drones matter so much in the 2025 to 2027 landscape. Companies now rely on drones because they detect defects faster, remove human risk, and cut inspection costs dramatically, which makes this technology highly attractive to recruiters. As you explore this domain, picture real scenarios like spotting damaged insulators on power lines, finding cracks on wind turbine blades, assessing corrosion on bridges, detecting hotspots on solar panels, or identifying weathering on tall building facades. All of these tasks depend on strong computer vision pipelines, smart flight control, and accurate anomaly detection. These use cases connect directly to deep learning, edge AI, and geospatial processing skills that employers look for, especially in energy utilities, construction, telecom, and government infrastructure teams. Drone inspection AI is not just a cool project. It's a career-ready skill set that places you at the intersection of AI innovation and real-world impact. To build drone inspection AI effectively, you need a strong mix of technical depth, industry tools, and professional soft skills that help you work safely in high-stakes environments. At the technical level, you'll work with core computer vision concepts, object detection models, image stitching, and deep learning techniques used to classify cracks, corrosion, and structural damage. You'll also explore drone programming, flight control, and geospatial data processing, which help drones navigate accurately and build detailed inspection maps. Tools like OpenCV, PyTorch, YOLO, DroneKit, ROS, Cloud Compare, and QGIS allow you to build everything from detection pipelines to 3D reconstructions of infrastructure. Recruiters value candidates who can combine AI with robotics because it's rare, practical, and extremely relevant for real inspection tasks. Soft skills matter too, because infrastructure inspection requires understanding safety rules, documenting findings clearly, and collaborating with engineers from civil, electrical, and mechanical backgrounds. Companies look for people who can assess risks, communicate results, and maintain accuracy in challenging outdoor environments. Learning these skills not only prepares you for inspection projects, but places you in a competitive position for emerging roles in edge AI, aerial robotics, and automated monitoring systems, fields that are hiring aggressively over the next several years. Now let's walk through the implementation roadmap so you can clearly understand how a drone inspection AI project unfolds from start to finish. The journey begins with defining the inspection scope, where you choose what structure you want to analyze and identify the types of defects you need to detect, such as cracks, corrosion, or damaged components. After this, you collect aerial imagery using drones, ensuring proper angles, lighting, and labeled datasets that include both normal and defective samples. Next comes model development, where you train an object detection or segmentation model to identify defects with high accuracy and low false positives. You then move into flight planning, which is essential because drones must follow precise autonomous paths, avoid obstacles, and capture consistent coverage of structures. The final technical stage is building the reporting system, which converts model predictions into meaningful visuals like heat maps, 3D reconstructions, defect severity scores, and inspection summaries for stakeholders. Beginners usually need around 12 to 16 weeks to complete this project because it involves AI, drone handling, and data processing, while students with a computer vision or robotics background can complete it faster. This workflow mirrors what real companies expect, making it perfect preparation for production-grade inspection roles. Finally, let's look at the career and placement value this project creates for you, because drone inspection AI aligns directly with high-growth roles in robotics, automation, and infrastructure monitoring. Recruiters look for candidates who combine computer vision, deep learning, and autonomous systems expertise, and this project demonstrates exactly that. You become suitable for roles like computer vision engineer for drones, aerial robotics engineer, infrastructure AI specialist, or autonomous systems engineer. Companies such as DJI, Skydio, Drone Deploy, Measure, energy utilities, construction firms, and government agencies actively hire for these skills. They expect you to understand defect detection, RS, object detection pipelines, and safety regulations because drone operations must follow strict compliance rules. Resume keywords like drone inspection, YOLO, aerial robotics, segmentation, edge AI, ROS, and infrastructure monitoring help your profile stand out. In terms of salary, entry-level roles typically offer 9 to 17 lakh per year in India, and global opportunities often range from $95,000 to over $200,000 depending on experience. This is a future-proof career path, and mastering this project builds genuine industry-level confidence. Start building this today and put it on GitHub.